hear me well? Okay. So after this class, you will not be new to the DevOps. That is for sure. Okay. So you will say that we know DevOps. But how to implement in this, that you need to separately join the class. Okay. Now, let's take, but DevOps in my style. Okay. Not regular style. It is my style. Okay. So let's take two people here. I need two people. We'll say Vinoda. Okay. Vinod and Pradeepa. Siri. Let's now. Okay, let's take Pradeep. Where is Chitti gone? You Chittis are all here only, no? So yeah. So let's take, we have Vinod and then Pradeep. Guys, concentrate. So this is Vinod. And this is Pradeep. Okay. Okay, so we have Vinod and Pradeep. So consider Vinod is a developer. Who is it, Nana? He is a developer. And Pradeep is operations guy. Pradeep is operations guy. So now I gave, this is my company. For example, this is my company. So my company name is boom.com. For example, company name is boom.com. So I gave a requirement to develop one small application. Not small, good application. I gave a requirement to develop a good application. So who will be developing the application here? Vinod. So Vinod will be developing the application. So it can be in Java, it can be in .NET, it can be Python, in any kind of language. So basically, who is developing here? Vinod is developing. So Vinod has the team and he's developed the entire application. And what he do is, he will tell to Pradeep, hey Pradeep, I have completed developing the application. Can you please put into the server? Can you deploy the application into the server? Who will deploy, developer or Pradeep? Pradeep will be deploying the application, correct? So this is the server. So this is the server, and then we have application. So Pradeep went and then deployed the application into the server. That is good. And then this URL accessed by the customer. We have the customer here. This URL is accessed by the customer. Okay, Nana? This is very common, no? Yes or no? This is very common. So here developer develops the application, and the operations guy, what they do is they deploy the application. Right? Here, mostly developer and operations like these people like wife and husband type. Okay, so without their combination, nothing will happen. So here, all of a sudden, the URL is not working. All of a sudden, URL is not. That meaning my website, my application is not working. So that meaning if the application is not working, what will happen? How is the feeling of the customer? Customer will be happy or angry? Customer will be angry. Very nasty customer. Yeah. Is a very angry. So now what this customer will tell is, he will contact whom? He will contact me, saying that, hey Riaz, what happened? Your website is not working. Hey Riaz, what happened? Your website is not working. So to whom I need to talk now? The problem is, do I need to talk to Vinod or do I need to talk to Pradeep? Okay. Let's go to Pradeep, for example. So as you said, let's go to Pradeep. So what Pradeep did was, I asked, hey Pradeep, can you please check application is not working? What he do is, he logged into the server and checked. And he said, like, sir, everything is working fine. I don't know why application not working. My server is good. My server is good. And then to whom I need to talk to again? Vinod. So I went to Vinod and say, Babu Vinod, can you please uh, check the application is not working? Application not working. And they use, all the developers will use one dangerous word. How many, anyone developers here? No. So they'll use one dangerous word. This, you know what they say? It is working on my local machine. What they say? It is working on my local machine. Local machining in their laptop. In their laptop, the application is working fine. But does it make any sense to the customer? And this, correct. See, Swapna and guys, developers, please, do you agree with me with these words? Correct? Say they don't really care about the servers. They don't really care about the server. They'll say that I have given the code to you. And the code is clean code, working code. I don't know what you did on the server. Okay, it is working on my local machine. So this, we know this developer is not at all interested to log into the server also. And Vinod will say that it is working here. I don't know what happened there. When I went to Pradeep says that, sir, everything is working fine. I don't, something problem with the application. When I go to Vinod says the problem with the server. Pradeep say problem with the application. Problem with the server application. Do I am a VIP here or VP here? Huh? So who is the most affected person here? It's me only, no? So of course, client is the most affected person, but this client is giving hits to me only, right? So I am in more pressure, correct? So because I am for the client, what I'll say, Are Babu, client, no problem. People are working, no, please give me some time. So client will say, how much time? 1 hour, 1 hour. So then client will say that, okay, 1 hour, no problem, I'll manage. So I come to Vinod. Vinod will say, sir, Pradeep, Pradeep, what happened? Sir, Vinod, Pradeep. Here, super game will start. You know what is that game name? Blame game start. So Pradeep team will say that there is something problem with the code. And Vinod team will say that there's something problem with the server. Everything is working in my local machine. He did something there. So guys, when they're fighting with each other, my downtime is getting increased to the customer. I gave only 1 hour. Slowly it will move to 2 hours. But still here, no one is taking the responsibility. As a manager, how should I feel? As a manager, how should I feel? Yeah. You guys are fire, right? So I cannot keep on firing everyone, right? So here the problem is with the system. The problem is with the system. So I cannot expect Vinod as a developer to go and calicify in servers. And I cannot expect Pradeep as an operations guy to go and check something on the application side, which he don't know the code. So as a manager, what do I feel is I need one person who knows both. I need the person who knows both. So here, so this, okay, we need developers. We need developers to develop the application. And we need the operations guy to handle the operations. See here, we have developers. We have here developers, and we have operations guy. But there is some gray area in between. There is one gray area. So I don't want completely developers. Developers, I want you to concentrate only on the application. Operations guy, I want you to only concentrate on the server side. But I need some people, those who know the concept of both. So I need, like here, who is there? Dev plus operations. And those people are called Devops. So we need these people. It's quite common, right? That is my problem, right? So it's not a technology. It's not a technology at all. It's a model. What is it? DevOps is a model. It's not a technology. So it's just a model where you have so many models, waterfall models, and have you learned about so many? So, and then we have agile. Have you heard about agile? Right? And then we have, this is DevOps is also some kind of model. So now this model consists of, okay, now you understood how DevOps born, the birth of DevOps. So as a manager, I feel the pain because I want some people where they need to able to handle both. They need to have idea on the development side also. They need to have an idea on operation side also. And those people are called DevOps people, or we call it as DevOps engineers. You got it? Is it clear till here? So now, this is your on-premises. What is that? On-premises. So in on-premises, you have so many servers. Yes. So, and then we have the DevOps people. So what these people will do is, guys, all the DevOps operation they are doing in the on-premises in previous days, previous years. Now everyone are migrating from on-premises to cloud. Which cloud? Which cloud? AWS cloud. So now instead of doing DevOps in on-premises, now they are doing the DevOps in AWS. And that is why we call it as AWS DevOps. AWS DevOps. So I am clearly saying that. Did I told you in this batch only? So guys, people say AWS with DevOps, AWS with DevOps. I told you this already, right? So they don't completely go with the AWS. They'll just put the powder on the face, just like EC2, S3, and they'll put some boat to like that. So did they go deeper inside it? They don't, because their subject is DevOps, not AWS. So as a people like you, as you are starting up your career, you should be good in AWS also. You should be good in DevOps also. So first you need to go with A plus B. Then you go for AB. Right? Okay, now. So now, are you interested to know what DevOps engineers do? Are you interested to know what DevOps engineers will do? Okay. So these DevOps engineers, what they do is, and what are their roles and responsibilities? Let's go slowly now. Is it clear till here, everyone? Okay. So I'll mix AWS also a little bit. Okay. Because AWS is in my blood only, I cannot completely leave AWS from DevOps. Okay. So now, guys, eventually in our AWS, where do you go and deploy the application? Which service? EC2. Yes or no? We know that EC2. Okay, let's consider EC2. So let's say here I have, let's say here 1, 2, 3. How many EC2s are there? 3 EC2s are there. This is EC2, EC2, and EC2. Inside this, I have the application. Yes or no? Inside this, I have the application. Which type of application? Version 1? Can I put a version 1 application? Yes, that meaning first I have an application which is called version 1. So in my EC2 instances, I have this version 1, guys. Now, what developers will do? Developers will not keep quiet, no? What they do? They keep on developing the softwares and they will release version 2. After some time, they'll release version 3, 4, 5. So they'll keep on releasing the versions. Similarly, like your phone also, you have the versions, right? So you'll update the operating systems, right? Similarly, Windows 10 you have, 11 you have, right? So like this, you have upgrades and updates on your, okay. So on your application. So who will be developing the application? Who will be developing the application? Developers. So now, is it only one developer who will develop all the application? No, you'll be having multiple developers. Should I call it as Day 1, Day 2, and Day 3 developers, 3 developers, for example. Okay. So Day 1, developer 1, developer 2, and developer 3. Okay. So a project. If you take a project is the collection of modules. Agree? A project meaning a collection of modules. If I have a project, what will I do is I split that in modules and I'll assign, let's say, for example, these are developers here. So I'll give one module to Ajay, I'll give one module to Manish, I'll give one module to Pradeep, I'll give one module to, so one person I'll give like this. Yes or no? Now, how many developers are there here? 3 developers. How many modules? Assume that we have. So developer 1 is doing module 1, he's doing module 2, and he's doing module 3. Guys, now where they do the development? They do the development in their laptop only. Yes or no? In their machine only they'll do. Correct? In their machine only they are doing the development. So what they do is at the morning to evening, they do Bava code, Bava, Java, .NET, Bava. So morning to evening, they put lot of efforts and then they'll try to develop the code. Let's say within one day they can develop the code? No. So let's say it took 2, 3, 4, 5 days. Okay. So basically before this, in real time, how it works is basically, hold on, Swapna. Okay. Let's get others also. So guys, those who already know DevOps, just listen because this is for those who don't know about the DevOps. Okay. So now in the real time, we have something called sprints. What's that? Sprint. So as you guys are small, like freshers, so when you go to the companies, how the work will assign is basically assume, let's say I am the PO. PO meaning product owner. Who is that? So we have a concept called PO, product owner. So what I do is I'll go to the customer. I'll be in touch with the customer. Let's assume that we are developing a, so you are all my team members. So I am the PO, product owners. We are developing a product. So I'll be going to the customer and say, Babu, customer, what do you want? And customer will say, I want that, this, that, this. He'll give very big list. So what I do as a product owner, I know about the product, no? So what I do is I come and I'll call team leaders. So I'll come team leaders, come. So I will be discussing with the team leaders, Babu, this is the customer requirement. Go and analyze what he said and then come up with different modules. So these team leaders, what they do is they analyze it, and what they do is they will split into the task. They're split into the task. So let's say let's say you have 20 tasks. So I have my 20 people, no? Right? All my 20 people, what it is, I'll be giving this task to each and every person. I'll give one task to Ajay. I'll give one task to Manish. I'll give one task to that. I'll give it a task for everyone. So now I need to give time, no? How much time? Will you keep on doing, developing the task? No. I need to give that. The sprint times can be 1 week or 2 weeks. The sprint time can be 1 week or 2 weeks. So within 1 week or within 2 weeks, you need to complete the task. And every day when you're doing so I need to get an update. No, your team leader should get an update what you're doing. For that reason, every day in the morning when you come to office, there is something called daily scrum will be there. What is there? Daily scrum. Daily scrum meaning, right? So daily scrum meaning the updates. You need to give the updates to team leader or scrum master. There will be one guy called scrum master. So scrum master also you have positions. Okay, so that is also a separate wing where it is related to process management. Have you heard about ITIL? Right? ITL, process management, and then incident management and problem management. So everything, basically, that wing is completely different. So those guys mainly focus on the process, how people are developing, how from which is the first step, which is the second step, which is the third step, like this. Okay, finally, you need to give this update to that Scrum Master. You need to give the update to the Scrum Master. And then Scrum Master, end of the day, he will give update to the product owner. So I'll get to know how the development is going, because all of a sudden after 1 month, guys, after 1 month, if you guys are not giving daily update to the team leaders or scrum master, and there are no daily updates, after 1 month, I come and ask you, Babu, what happened to the task? Everyone, yes, sir, we completed all the tasks. When I went and see the task, that is completely opposite. What should I say to customer? You have wasted how much time? 1 month. So this is the called waterfall model. What is that? Waterfall model meaning, so you cannot get the updates every day, right? And then you need to reinvent the complete wheel. Again, you need to back to starting. So that's why this sprint model, what it does, this sprint model, every day you update the task, and I'll get the scrum masters get the updates, and then he will give the updates. So this is not related to DevOps. Okay, this is completely different. So this is how the tasks are assigned in your real time. Okay. Now come back here. Okay. So we have 3 developers, developer 1, developer 2, and then developer 3. So from morning to evening, they develop the code. For 1 week, they develop the code. Where is the code now? In their laptops, in their local machine. All of a sudden, after 1 week, laptop from first floor to ground floor, it fell down. iPad. So the laptop crashed. So whatever the development she or he did for 1 week is gone. So now you tell me, is it recommended to keep your code locally in your laptop? No. How dangerous it is. All of a sudden, Pusuk, the laptop crashed, got virus, or someone deleted it. And the efforts that you have put as a developer for these many days is gone. And the billing time is also gone. What I should tell to the customer? Should I tell that the laptop is crashed? He'll say, poo. Right? So it's not good, right? So for that reason, now you tell me, is it recommended to keep the code in the local machine? No. Where should we keep the code? Somewhere centrally we need to keep the code. Somewhere centrally we need to keep the code. Correct? So now developer 1, from morning to evening, he developed the code, and end of the day, he need to push this code to the central repository. Repository meaning is nothing but directory. Okay, folder. So can we maintain a central repository? For that central repository, we call in DevOps, there is a tool to manage this. We call it as Git. What we call it as? Git. Git is a tool. Git is a tool. So this is the first tool that we got in DevOps. So what is the tool name? Git. So now, can I keep all these things here in the central repository? So this is my central repository. Okay, central repository. So now my M1 module, M2 module, M3 module, everything will be inside the central repository. What is the central repository? There are so many tools available. So I call it as Git. What is Nana? And we call it as, we also have GitHub. What we call? GitHub. We have GitLab, and we have Bitbucket. So there are so many tools available in the market. There are so many tools. These are all called version control repositories, central repository. Version control. That meaning today you develop the code and you pushed to the central repository. Tomorrow you develop another code, you push it. So version 1, version 2. So all kind of versions will be there inside the central repository. You understood? So Git is a central repository, is a tool where you can install on the some server, on centralized server, you can install it, but you need to maintain it. No, what happened? Pusuk, that Git server went down. All your code is gone. So for that reason, instead of going to the Git company itself, right? So they have something called GitHub, that is cloud-based repository. Which one? Cloud-based. GitHub meaning if you go to the internet and type GitHub, everything is into the website. You just create a repository and upload all your files there. Simple. But whereas Git meaning You need to install Git in your machine, create repository, into maintain. You need to do so much of things for the Git server. But if you go to GitHub, everything is managed by Git, the people only in the back. It is cloud based. So which one is easy? Git or GitHub? GitHub is easy. Similarly, here also we have Bitbucket. Bitbucket is also another company, Atlassian company, where they also provide the same. So based on your company's requirement, people work with the GitLab or GitHub, and then they go over the Bitbucket also. So anything they can use, any tool. So what I'm telling here is, out of all these tools, you should be perfect in one tool. So I would vote for GitHub. So you should be good for in GitHub. So now, guys, now developer one, see here, developer one has developed the code, and what he do? He pushed that code to the repository. What he do, Nana? What he do? Use the word push. What he do? He push. All these developers, what they do is they'll push the code to the central repository. They push. Okay. Push. 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 Yes, it is a kill. So they will push. Once, okay, they develop the code. They develop the code in their laptop, and what they do, all the code, they track it, and they'll say that they push it. So all the code will get pushed to the central repository, can be GitHub. Okay, Nana? So now, once you push, you need to say no. Yes. You need to commit it. What you need to do? Commit. Commit is completely, okay, I'm done, save it. Commit is nothing but, you have no, okay, sorry, commit. Right? So similarly, once he has committed, right, he will not listen, right? Because it is completely fixed. So here also commit is nothing but saving all the files in your repository. So now here, what we need to do, we need to commit it. You push it and then commit it. Now let's say, for example, new developer joined the company. Developer 4. See, developer 4. Now developer 4 wants to develop the code. Developer 4 wants to develop the code. So that meaning he need to know about M1, M2, M3 modules, no? So this developer 4 will go and ask, hey, developer 1, can you give me the code? Hey, developer 2, can you give me the code? Hey, developer 3, can you give me that code? Will you go and keep on asking the developers? No, where is all your code now? In the center repository. All they push it, no. What this developer for, what he need to do? He need to pull. What he need to do? He need to pull. Push, pull. Push, pull. So the Git is all about pushing, pulling, committing. Right? So now here, from here, what he'll do, developer 4 will pull the code. Okay, so the problem here is, guys, the problem here is, in repository, in central repository, in GitHub or Bitbucket, wherever you go, everyone are pushing the code, right? There will be one directory, one folder. All the people are pushing into that directory. That is your main directory, no? Your main directory. Can we call it as master? So instead of calling master directory, can we call it as master branch? We have a concept called branches. What is that? Branches. So the main, we call it as master branch. What we call it as? Master branch. We call it as master branch. Now you tell me, developer 1, developer 2, 3, 4, everyone can directly push it to the master. Can directly push it to the master. Master has a clean code all the time. Similarly, developer 5 came. He wrote Bootu code, very bad code, and he pushed. Already clean code is there in master. This Bootu code also went in there, and entire code has become Bootu now. That very bad. So all the developers should have access to the master branch? No. They will push to the master branch directly? No. So what they do is they need to create their own branch. Yes or no? What they need to do? They need to create their own branch. So developer one create the own branch, right? So here, let's say for example, here I have a master branch. Master branch. Okay, now? So we have developers, no? What developers? Day 1, okay, Day 2. So they can create their own branch? Yes or no? They create as M1 branch as he's working on, and they can create M2 branch? Yes or no? Yes or no? So they create their own branch, okay? And what they do is, this developer will push the code to where? Which branch? Master branch or M1 branch? They will push the code to M1 branch. Developer 2 will push goes to M2 branch because it is their own branch. They can do whatever. And finally, what they do is they'll tell manager or team leader, hi, Mr. Team Leader. So I have completed my task. My entire code is in that branch. Please look into it. Team leader, what he do? He'll go it and then he will do the code review. What he'll do? Code review he'll do. So once he did the code review, so in we call it as a reviewer or code reviewer. So what he do? He does the code review. So he'll do the code. Once the code review is done, it's fine, no? Once the code is done, if it is good, that's fine. If it is bad, he'll tell Babu, please pull the code again. And these are the problems. You work and then push it again. Once the code is clean, then what he do? He will merge it. He will merge to where? Which branch? Master branch. He will merge to master branch. And like this, guys, like this, you have the team leaders, you have the developers, and on top of it, you have seniors, on top of it, you have team leaders, on top of it, you have managers. So all this will go as per the process. So end of the day, the master branch will have the clean code. Yes or no? Master branch have the clean code. You understood? This is the overview of the Git. So Git is all about few commands. So you need to add. So we need to add all the files for tracking. Okay, now in your local machine you have 5 files. How does the Git know that you have 5 files? How does the Git know that Git should track your files? So you need to first Git add. You need to Git add the files, and then what you need to push the files. You need to commit the files to the repository. Whenever you require, you can you clone it also? Let's say developer 4 is there, right? Developer 4 is there. Developer 4 pull is nothing but can he clone it? Can he clone the entire repository? Yes. Now let's say I'm the TL. Ajay has developed in M1 branch. Can I call that? Can I clone it? And can I work and can I see what he has developed? Yes. So it is all about here. Pull, add, pull, push, commit, merge, and code reviews. Everything will happen in the Git level. How much good this process is, that much clean code you will get it on the repository. Okay, Nana? You understood, everyone? Git in few minutes. Get clone meaning, let's say you have the directory. Clone meaning copy the same files into your local. That is nothing but clone. Okay. So now, fine. Okay, ma. So assume, guys, assume this repository has a latest code. So can I call this as SCM? SCM. Honestly, slowly people are asking questions, huh? Sir, how to resolve conflicts? What is conflict? Conflict meaning, so if you have 2 same files, right? So you are pushing some data and that guy also pushing the same data, and conflict will happen with the code. And whose code is the best? Whose code is correct? So as a manager, as a people, you have to check the conflicts. Which one is correct, you need to put it, and then rest you need to remove it. So in Git, you will get all these commands. You need to learn all these commands. Okay. Okay. Now this repository, guys, this GitHub, we call it as SCM, source code management. What is that? Source code management. Source code management. We call it as SCM. Understood? This is one part. So now, correct, Prabhat. Yes. And now, you have the code on the master branch. So the next step here in the DevOps is you need to build the code. What do you need to do? So you need to build it, right? Yes. So the next phase is build phase. The next phase is build phase. So to build your code, there are so many tools available. Have you tell me? Maven, Ant, Gradle, Jenkins, etc. So there are so many tools available to build purpose. So what this will do is it will build the entire code and check whether there are any errors or not. So what this will do is, okay, so once everything is built, if build is successful, you have a clean code. If build fails, that meaning there is something problem in the code. Can it go to the next level? No. So here, if build fails, it will come back to the developers again. If build, okay, now build fail. So here build fail. Okay, build fail. And it will come to the developers and developers will check what is the problem. Now, if build is pass, and similarly, while building it, now testers will come into picture here. Who is it? And what they do is they will write the test cases. Let's say, for example, you can take any. Let's say, what should I do? So basically, what the tester will do is entire code is properly working or not. Let's say you take Facebook. Facebook is opening or not. Username, password is there, no? Username beside text box is there or not? It is taking the value or not? How many numbers it taking? What is the syntax it is taking? What is the password you're giving? It is matching or not? So all the possible test cases they will write. The job of the testers is only to write the test cases. They can write it manual also. They can do the automation testing also. So for automation testing, nowadays, have you heard about Selenium? Right, that is related to your automation testing. So instead of you going writing each and every test case, let's say I need to remove this bag. So first I need to touch the bag. That is one test case. Am I feeling the bag? That is second test case. I'm lifting the bag, third test case. I'm putting it, fourth test case. Putting sound is coming or not. So everything, so everything is a test case there. Right? So now, so let's say, for example, using Maven, using Ant, using Gradle, or using Jenkins. Name this, read this. Maven, Ant, Gradle, and Jenkins. So any of the tool you can use for the build purpose. So Java people mostly they go with Maven, right? And also basically Jenkins also good for your build purpose. Okay, now let's say, for example, the build is passed. Okay, the build is passed. The build is passed. So I told you, testing will happen, right? So here, while doing the build itself, testing phase also will come into picture. Testing. For testing, what is the thing that you use? Selenium. And also JUnit for Java people. So JUnit is also one more tool where it is used for testing purpose. Okay. Now testing is done. So guys, here, see here, you have built it, no? Entire code got built and then you tested it. So your code is clean now. So finally it will generate one zip file or war file, no? Finally, executable. Executable, correct as or no? That executable, we call it as artifact. What we call? Artifact. Artifact is nothing but zip file. The entire code is zipped into one file. And that zip file will go. Now, yesterday we did the Beanstalk, no? In Beanstalk, what are we giving? Zip file only, no? That zip file is nothing but who will develop this zip file? Developers. This phase, you will get that zip file. After testing, once the testing is done, you will get a clean code, no? That clean code, that zip file, we call it as artifact. What is it, Nana? Artifact. So now, the next step here is to generate the artifacts. So, artifacts. So, artifacts for this, guys, where do you keep? There is a separate tools for this to keep the zip files. So, have you heard of, okay, Nexus you have, and you have JFrog. So, there are two tools, or there are many tools. Most common tools are Nexus and JFrog. So, your artifacts are stored where? In Nexus or JFrog. Where do you save all the artifacts, guys? In Nexus or JFrog. So that meaning you keep your zip file, you keep your war files, etc. You keep it here. Okay. Now the zip file is ready. In yesterday we did Beanstalk, no? And you have the zip file ready. It has to go through all this process to get that zip file. Clean code. And that zip file, what you do? You go and deploy. So the next phase here is deployment. So because we have the clean code, no? So we have the clean code. Now we go and deploy. The next one is deployment. It is deployment. So for deployment, what are the tools that you use? Jenkins are multi-used. Actually, Jenkins is good for build only, but people also using Jenkins, they'll deploy. So they will go with Jenkins. They go for Bamboo. Experienced people, tell me. TeamCity, Circle CI. What else? CloudBees, etc. There are so many tools are available, right? So this deployment can be done using these tools. In these tools, you need to configure. And say that, okay, where are you going and deploying it? On the EC2. So this Jenkins or Bamboo or TeamCity or Circle CI, what they do? You have the version 2 zip file, no? That version 2 zip file will go and deployed into this EC2 instances. Okay. You got it? Okay. So now let's say, for example, you have so many EC2 instances are there. How many? So many are there. And you want to do some configuration changes. Some file, or you need to install something, or you need to do something on multiple EC2 instances. Is it possible for you to go and do it manually? Is it possible for you to go and do it manually? Online guys, tell me yes or no. So no. For that, you have a concept called configuration management tools. Configuration management tools. So for configuration management tools, what are the tools that you have? You have Ansible. What is that? Ansible. You have Chef. You have Puppet. What are the tools you have? Ansible, Chef, and Puppet. Chef, Puppet are old tools. But there might be some companies, they might be using Chef and Puppet. But nowadays, everyone are using what? Ansible. So in Ansible, you need to write playbooks. What you need to write? Playbooks. Playbooks. Have you heard about YAML files? YAML, YAML. So that's similarly like YAML. You need to write here playbooks. So you have the playbooks. So you write the script there, and then these playbooks will go and do the configurations automatically in all the EC2 instances. Got it, Nana? Okay. So now, what are the phases we have here? Tell me. First, we have Git phase, and then build phase and source code management, and then build phase, and then test phase, and then artifacts, and then deployment. So now, if I want to put version 2, developers, what they do is, guys, developers, they develop version 2 and then they commit it. Yes or no? They commit to the source code. So now, once it is committed, can you tell me, will you be there? And then, oh, this guy is committed, I need to go and build, click. Will you do it manually? It should be integrated continuously, no? Once someone is committed to the master branch, automatically build should happen. Automatically test should happen. Automatically artifact should create it. Automatically deployment should happen. So this is called continuous integration. What is this called? Continuous integration. So you need to integrate all these phases, all these tools. This is called continuous integration. Once you continuously integrated all these tools, and continuous deployments will happen. Continuous deployments. So once you deployed, who is the end guy who is accessing the application? Customer. So we are doing the delivery to the customer. That is called continuous delivery. So continuous integration, continuous deployment, and continuous delivery. This is called continuous integration, we call CI. Continuous deployment, we call CD. And this entire process is called CI/CD process. So this is called CI/CD process. So this entire integration, you need to create, what you need to create? You need to create something called pipeline. What you need to create, Nana? Pipeline. So that pipeline is the combination of all your SCM, build, test, artifact, deploy, everything will come into one pipeline. If you trigger that pipeline, automatically all this will get triggered. So if anyone who's committed, that's why committing to the master branch will be done by the managers only. If he say that, oh, this is my latest code, if he commit, then entire process will be automatically happen and the deployment will be happening on the machines with version 2. If something fails, it is fails here only in between. And if your continuous pipeline fails, that meaning deployment will happen, it will not happen. So guys, and there is some question, Shubhanshu is asking, what if something fails? Why do you have dev environment? Why do you have test environment? Why do you have QA environment? Why do you have UAT environment? Why you have pre-prod environment? You have 5 environments. So all these testings should be done in all this environment first. So I'll write it here. What are the environment? First you have what environment? Dev environment. Then test environment. Then QA environment. Then UAT environment. Then pre-prod. Then prod. Test or stage, anything, both are same. Do you see this? So all this entire pipeline should be done on the QA also, should be done on the UAT also, and should be done on the pre-prod also. Once you have done on pre-prod, pre-prod is nothing but what? The name itself says pre-prod. Pre-prod meaning what? It is same as production only. It is same as production only. Look and everything is same, but your customer is accessing pre-prod or prod? Prod. So it is pre-prod is both are it's clone of production. If it is working in pre-prod, it should work on prod. So you guys will be doing everything in the pre-prod first. Make sure everything is good. Then only you go and deploy on the prod. In prod, there should not be any question if something fails. You should not have any question related to fail. It should pass. Don't play with the production environments. It's a huge loss for the company. So for that reason, you need to play with the before stages, you can go for it. Now, is this clear till here? So do you all understand what is pipeline? Okay. So now the question here is, okay, see here, guys, see here. Can you deploy application on your physical machine also using this? Yes. Can you deploy on physical machine? Yes or no? You can deploy on the physical machine also. The physical machine has what? Hardware, OS, application. But do we have any physical machines anymore? No, this is a physical server. Okay. So from physical, we have migrated to which one? Which technology? Virtualization. Remember? So in your company, you have virtualization. This Devops can be done your on-premises also using the virtualization. This is a host machine. Okay. So see here, this is hardware. On top of it, you have hypervisor. On top of it, all these things are virtual machines. All these are all virtual machines. So can you deploy on your virtual machines also here? Yes. But do we have virtualization concept? Do we have on-premises? No. Okay. Now this virtualization, everything is handled by whom? In AWS only, no? So this virtual machines is nothing but EC2? Yes. You can deploy on your EC2. So your end, where do you go and do the deployment? On the EC2. But nowadays, you got another technology. Should I tell you that technology? See here. So you take this you can take this as a virtual machine also. You take this as a virtual machine also. You can take this as a physical machine also. Anything is fine. Okay. So on top of it, it is very important. See here, you have a hardware, you have operating system. Here we have a hardware and we have a OS. This hardware can be virtual or physical. Okay. Generally on operating, what we have here, virtual machines, no? Generally we should have a virtual machine. Instead of virtual, guys, if you take EC2 or if you take a virtual machine, that is a machine, no? It has operating system, it has a hardware, it has an operating system. On top of it, you have a application. So one virtual machine consists of operating system. Yes or no? Every virtual machine will have an operating system. Yes. Isn't it heavy? So next technology, we have a concept called containers. What is that called? Instead of creating virtual machines, you are creating something called containers. So containers. So in each container, you can have application inside it. Do you need operating system? No, guys. No operating system. Without operating system, you have what? Applications. If you don't want operating system and if you want to have application to run in one machine, you don't need to create virtual machines. You need to create containers, and each container, it is a very, it's very, very light. Doesn't have any operating system. Just to create a container, put the application. Bas. And this here we call it as Docker. So Docker containers, we call it as Docker containers. So using Docker software, what you can do is you can create the containers like this. And this one, we call it as microservices. What are these called? Microservices. So your code will run based on this operating system. Okay. Srikanth. So these are containers. You understood what is correct? So Docker is a company. Yes, Docker is a company, and you can install this Dockers in your machines, and then you can create the containers like this. So now we have multiple applications, but if you want to have the cluster, what is cluster? Generally, what is cluster? Group of servers. What is cluster? Group of servers. And if you want to have a group of Docker containers, you need to make an high availability. If you want to group the multiple things. So guys, in Docker itself also there is a concept called Docker Swarm, but we have something called Docker Swarm. So Docker Swarm is used for cluster concept, but that is old. That is become old. Nowadays, we have got something here. We call it as, okay, we call it as Kubernetes. What is what? Kubernetes. So Kubernetes meaning it contains Docker containers only. It contains Docker containers only, but in the form of clusters. So it contains Docker container. It's a form of clusters. Okay. And these clusters will be easily maintained by Kubernetes. In simple way, people also call it as K8s. Understood? So this Kubernetes can easily manage all your clusters. So finally, your application can be in which places? Finally, applications can be in EC2. Applications can be in containers. Yes or no? Or applications can be in also Kubernetes. But the backend process is completely same. So here, end of the day, you are updating the application here, right? So this place can be EC2, this place can be Docker containers, and this place can be your Kubernetes. This is what DevOps people do. DevOps in nutshell. And should I give one more extra? See, sir, how do we do in AWS? Guys, listen carefully. Which color should I use? Okay. So, if you want to go for the Git, you need to install Git, maintain Git, handle stuff, everything. And or also you can go for GitHub. If your infrastructure is in AWS, will you go for GitHub outside? Similarly, as a GitHub, AWS has a service called Code Commit. You can forget about GitHub. Code Commit is completely managed by AWS. Create directory and push the files. For build phase, do you need Maven, Ant, Gradle, Jenkins? No. In AWS, we have code deploy. In AWS, we have what? Code deploy. So for artifacts, can I put all the files in S3? Sure. And also, and there is called code artifact. If you want, you can put it as. And then for deployment, AWS has, here it is code build, not code deploy. Here it is called code build. Okay, here we call it as code deploy. So all the tools are now completely handled by AWS. So code deploy. Can you deploy in EC2? Yes. Can you deploy in Docker? You don't need to install Docker, you need to configure Docker, you don't need to do anything. In AWS, there is a completely managed service by AWS that is called ECS. What is that? ECS, Elastic Container Service. Elastic Container Services. No need to install Docker, nothing. Everything is complete. You need just to connect and create it. That's it. And then here also Kubernetes, you don't need to set up. In AWS, we have EKS, which is called Elastic Kubernetes Service. Completely managed by AWS. No installation, nothing is required. Got it, Nana? This is the whole thing of DevOps. So tools. There should be one image. Let's take, for example, I take this image. Guys, by the way, to monitor all these things, we need to have monitoring tool, no? In AWS, it is CloudWatch. So in third party, you can go with for monitoring. There are so many tools are available. For monitor, you have Splunk, Grafana, Kibana, and there are so many. Nagios, right? OpsView, Vagrant. There's so many. Right? There are so many. I cannot list all these things here. So for monitoring purpose, you have so many things here. So what I wanted to show you is, okay, let's say for example, and did I tell you about this also? I cannot leave you saying all these things. Huh? We have something called infrastructure as a code. What is it, Nana? Till now, in AWS, we are going and doing manually, launching the EC2 instance, creating load balancer, creating that, this and all, right? So we have been doing everything manually from the console. But developers, what they do is, they can code everything. There is a tool called Terraform. What is that, Nana? So Terraform is a third-party tool where you can write the code and then just apply that code, automatically entire infrastructure will get created. If you want to automate the infrastructure, if you want to create a VPC, create a EC2, create a load balancer, create auto scaling, for everything there is a code. You write the code once, keep it, and then if you want to create a load balancer, no need to go to console. Open that code and then hit enter and the load balancer will get created. You just need to give the parameters in Terraform. So similarly, like Terraform, if you ask, sir, what is there in AWS? In AWS, we have Cloud Formation. What is that, Nana? So Cloud Formation is an AWS tool where you can automate your entire AWS infrastructure. Got it? Okay, so copy image. Okay, do you see this here? If you see this, what are the phases you have? First, you need to plan it, and then code it, and then build it, and then test it, and then release it. Release it, and then deploy it, operate it, and then monitor it. So these are the DevOps phases. So in each and every phase, we have already learned. Let's say, for example, for planning, can we go for the sprint? I told you about sprint. You can go with the planning. And for Gradle, we've seen, right? Bamboo, right? Puppet, Chef, Dockers, right? And then can you go with the for automating your infrastructure? Go with the Terraform, right? Kubernetes, Nagios, Git, Jenkins. See, did we cover all these things? So if you learn all these tools, so all these tools will be in DevOps. They will teach you nicely. So do you got an idea of the whole DevOps now? Right? DevOps in one class. Okay. So I hope you like this DevOps class. Any question? How is the class? Don't ask me to teach DevOps. Nice. So those who those who are already working in DevOps. So this makes sense. How is this for you? Those who know already DevOps. Did we cover everything here? Yes. Fantastic. Like Ansible, do you have anything in AWS? Yes, there are few. Akhil. Nana, got it? Clear? Nice. So take the screenshot. And by the way, guys, see here. Okay, now tell me, see here, guys, Chiti. So there people are asking, sir, will you teach ECS? Will you teach Kubernetes? Will you teach EKS? Will you teach Kubernetes? Okay. Thank you, Anand Kishore. You are the Superman of trainers. Huh? Okay, thank you. So I don't mind. But the thing is, in order to learn these things, first you need to learn core DevOps first. What you need to learn? Core DevOps. So in ECS, guys, in ECS or EKS, there is nothing. You go and create cluster or go and create a container service, containers. That's it. But you should know what is container, how do you create it, how to create the containers, how to port it, how to host it, how to create it. Everything you should know. Then only you go for the automated level. This in AWS, these are all next level. So first you need to learn DevOps and then go to the next level in AWS here. So without learning DevOps, if I teach you ECS, you don't understand. Better I keep AWS aside and teach DevOps first, which will not happen. So for that reason, so first learn DevOps. Once you learn DevOps, then you can implement these DevOps tools in AWS with ECS, EKS, code commit, code pipeline, everything you can do it. Okay, ma'am? So tomorrow we have class. Okay. Tomorrow we have class and tomorrow we'll take another service. Super. I tried to log in an application. I got 502 server, bad gateway. What is my problem? We are using AWS servers. Anil, your application is not working in the backend. So, or else it is not reaching to the server. So if you have any reverse proxy, okay. No, not about security groups. Let's say you have multiple servers. First, it has to go to one server. From there, it goes to another server. From there, it goes to another server. Let's say if you have any reverse proxies in between, if it reaches there and reverse proxy is not contacting your application server, then it shows bad gateway. So please check on that error. Bad gateway meaning it is not reaching the server at all. Okay, can you give the final CC for today? Thank you, Meghana. So guys, don't worry. So most of thinking, sir, how do you remember all these things? How do you know all these things? How many are there? How many years? 17 years of experience, Babu. So in this experience, so I might look very small, isn't it? Laughing meaning, I look young only, no? Okay, right, yeah. So in these years, so we have seen so many technologies. I, I started from where, when I was in my college days, I still remember to my dad, I used to write letters. There was no phones at that times. No phones. So we used to write letters, envelope letter, and you have the yellow letter card, no? So we used to write that letters, and then I still remember in my degree college, in my college, at that time phones came. The first phone I used was Nokia, that big that phone, right? 1100. So so at that time, and when I was kid, there was no computer at all. So I still remember we used to go to a computer school or computer institute, and there is no operating system on those days. It was only DOS. I told you, disk operating system, only command based. So I have seen evolving, and tell me, have you seen 5 paisa coin? 1 paisa. We used 1 paisa, 5 paisa, 20. You might seen 25 paisa or 50 paisa. You might have seen, right? So if I tell all these things, you can calculate my age. No, I don't want to. Okay, so good. Uh, you don't want to leave me, right? There is a lot of things you need to change. Okay, okay, good. Okay, nice. Okay, so thank you guys. That is all for today. And no, Shubhanshu, no. Okay, so if you guys want to see me, come and don't put photos and all. Okay. So that is all, guys, for today, and I'll see you tomorrow with the next AWS service. Until then, take care. Bye bye. Have a nice day, and see you tomorrow. Don't miss the class. Tomorrow is very important service. Okay. Bye bye, guys.